Hi folks, welcome back for more sneaky equations. In the last video we looked at quadratics. In this one we're going to look at ones where you have identities that you can use, or you might have just nothing that you can do other than try and build a tangent. So if you have two different trig ratios, try to use an identity to write it in terms of one ratio, especially if there are squared terms. And here's one thing that we established before. Sine squared plus cos squared theta equals 1. And some things that followed from there were that sine squared theta could be written as 1 minus cos squared theta. We just move that cos squared to the other side. And that cos squared theta could be written as 1 minus sine squared theta. So let's look at this equation below. It's got a cosine and a sine squared in it. That's not great. We have different ratios. The one that is easier to get rid of is actually the sine squared, because it has a different definition right over here. Sine squared is 1 minus cos squared. Now, do we know that that's going to help us? Not really, but it's a thing that we can try. Okay, so we'll just put it in there, and we'll go 1 minus cos squared theta. Now we have it written in a single trig ratio, and now it looks like a quadratic trig equation, just like we did up here, and here, and here in the last video. So I can move all my stuff to one side. That cos squared is going to come over to the left-hand side because I'd like to have it positive, plus 2 cos theta. And I'm going to subtract off that 1, so I'll have just plus 1. So that's just rearranging the equation. Let me make it clear what I've done here. I've added cos squared to both sides. I have subtracted 1 from each side, and now I have this new quadratic equation. And it's hopefully factorable. Let's go off to dreamland and say, what if it had been y squared plus 2y plus 1 equals 0? That'll be a short trinomial. It could factor as y plus 1 by y plus 1, okay, which means we'd have numbers that add to 2, multiply to 1, or better yet, just y plus 1 squared. As a result, this cosine equation over here, it can just factor to cos theta plus 1 squared equals 0. And that in turn really just gives us one elementary equation that's doubled to solve. It doesn't really matter that it's doubled. Cos theta equals negative 1. And let's check it out here. Negative 1, 0 would be back here. Okay, so we'd get an answer of theta equals pi. So to recap, we figured out that we had a problem because we had sines and cosines, but one of them was a squared term, so we could use these Pythagorean identities, or variations on this single Pythagorean identity, to rewrite sine squared as 1 minus cos squared. Here's another one. And in this case, it's harder to rearrange, or it's harder to use Pythagorean identity, because neither of these terms are squared. So, I mean, you could use some square roots, but you're going to have a plus or minus in there. It's going to be real bad. So as a last resort, you can try and build a tangent function. And we have this identity, that tan theta is just sine over cosine. So if I can write this in sine over cosine form, then that will help. Let's see. So to do that, I'm going to have to separate out my sine and my cosine. This is only going to be possible if there's no constant term. And the next thing I'm going to do is I'm going to divide by cosine, because what I'm trying to build is a sine over cosine. So let's see, what do I have now? I would just have root 3 equals negative sine x over cosine x. Oh my gosh. Negative sine x over cos x would be negative tan x. Okay, and that's not quite in an ideal form yet. You probably want to multiply both sides by negative 1, or divide by negative 1, or flip the signs, however you want to think of it. If negative tan x is root 3, then tan x is negative root 3. At this point, we're ready to go and hunt down a reference angle. Okay, and it turns out that that reference angle is going to be at pi over 3. You'll be at this point here, 1/2 root 3 over 2. Okay, and the tangent there is going to be root 3. So let's find the rest of this. Reference angle is pi over 3. Tangent is negative in the final version of this equation, so it could be in the second quadrant or the fourth quadrant. And we're just going to find these angles. This one here would be pi take away pi over 3, okay, or 2 pi over 3. And this one over here would be 2 pi minus pi over 3, which would be 5 pi over 3. Okay, now if we're looking really carefully at this, we might notice that the domain's just from 0 to pi. So actually we don't need this answer. It's too far. The only one that we need in this case, because of the domain, is theta equals 2 pi over 3. So that's a couple of little tricks using those two identities that we know so far, that tan is sine over cosine, and that sine squared plus cos squared equals 1, to try and rewrite in a more usable form of the equation. In terms of practice, from the last video, I asked you to do 1, 2, 3, 4, and 8. And on this one, we'll do the remaining ones. And I think I foolishly forgot to put the answers up on the screen. If you didn't do the ones from the last one, maybe do all of these. And here are the alleged answers. Hopefully I didn't botch any of these. If we're not sure, then you can always check graphically and see what the decimal approximations were. Then we'll get a real good idea of what's the actual solution. Take care, and good luck with the material, folks.